Hello everyone. I'm Gurneet from AlmaBetter team, and welcome to today's masterclass on how Zomato uses machine learning. I'm thrilled to have you all here as we delve into the fascinating world of Zomato and its data-driven approaches to success. So today we have a very special guest with us, Arnav Kundu, who brings a wealth of experience in the data science and analytics domain. And Arnav will be guiding us through the insights and strategies employed by Zomato in harnessing the power of machine learning. So hi Arnav. Hello.
Hello, can you hear me?
Yeah.
Yeah, I'm really sorry. I think there is a problem in my internet. I'll just reconnect. Just give me 2 minutes, please.
Yeah, sure.
Hello, can you hear me, everyone? I hope everyone can hear me.
Yeah, Arnav, you're audible.
Yes, awesome. Cool. Thank you for waiting, and thank you for the welcome as well. I was able to hear just three words because of connection.
Yeah,
Uh, but again, glad to be back with the AlmaBetter team.
yeah,
Another day. So cool. So I think you would have given a brief introduction about what the today's agenda will be, right?
yeah, I
Because I
have.
wasn't able to hear properly, so I assume that it is done. So cool. So welcome everyone. Just a brief about myself. Anyone who doesn't know me, my name is Arnav. I'm working as a manager in analytics with AB Inbev, and again did my so I was few years back. I was in the same place as you guys were, as you guys are. So I also did my bachelor's masters from mechanical engineering, transition into the field of data science. Again, the same alma mater as the founders of the company, and that's why I'm very glad to be here with the AlmaBetter team. So today's
Yeah,
agenda, sure,
we are
sorry,
thrilled to have you.
thanks a lot. Cool. I hope everyone can see the presentation, right? Today's presentation.
Yeah, it's visible.
Cool. Today's agenda is on basically the how Zomato uses machine learning. Now, why Zomato? Why did we pick up Zomato? We could have picked up anything else. The main reason is there are a lot of known use cases that are solved by Zomato. Many of these use cases again um, are uh, are so generic that they are reusable anywhere else as well. So some of these things we use in our organizations as well. Uh, and um, yeah, so machine learning is one thing I guess we use day in day out. So I would say anywhere everybody would have used Google Maps, right? Again, this is not a lecture, right? This is more of an interaction. I would love everyone to kind of uh, keep talking to me with chat. So everybody would have used Google Maps, right? That's I think one of the most used app anywhere, right? Now Google Maps is basically an alternate to our earlier times when we were kids. Is an alternate to we used to stop at every place, ask some person, hey, where is this place? Where is this place, right? Google Maps has revolutionized the entire piece of stopping, asking anyone, and giving directions to reach a particular place, right? Now, some of these use cases of Google Maps, you would actually see how Zomato also leverages, how Zomato also makes sure that some of the route mapping and all, how they do it. So today's talk will be mostly about that, machine learning at Zomato, why Zomato, what are the different use cases we use at Zomato. And yeah, with that, let's get started, right? So now everybody of us knows Zomato mainly because of it's a online food ordering and delivery app, right? Primarily present over phones, right? So we use our phones mostly to kind of order online, get it delivered, right? Now, what we don't know that Zomato also leads to restaurant discovery and also has a revenue source which is advertising. Now, this is not what I am saying. These are all something which is there on blogs of Zomato as well. So if you sorry, if you see restaurant discovery, right, you would see that a lot of restaurants, right, a lot of restaurants, you would typically see something like an ad at the top, like there will be a Zomato, the name of the restaurant, right, and kind of ad or maybe written as sponsored. Anybody has seen, right? So those are nothing but an advertising space that Zomato gives to the restaurant so that they can put their restaurant names at the top, so that anybody who comes in first sees this restaurant who are within that particular vicinity and then order from their app, basically, right? So one, obviously it allows Zomato to earn money by selling that advertising space first, and obviously if somebody orders from that particular restaurant, it leads to the increase of the gross merchandise value or the average order value as well for Zomato as a whole, right? Now, again, two sources of revenue income. One is the ad sell, and the second one, if somebody orders, obviously the respective commission, right, is also as a different revenue source for the Zomato. That is one piece of it, right? Now, restaurant discovery. Now, anytime have you seen that Zomato, when they show, maybe they don't show ad, but they show something like a new, something like this. Has anyone seen? Right? So this is more about Zomato telling, hey, there is a new restaurant that has opened. This is more of like when we used to live in colonies or kind of communities, right? My dad, he's in a government service. So he used to live in communities, colonies. And over there used to be like always that thing with our moms that, hey, there is a new restaurant that is opened, right? Zomato actually acts like that, right? Saying that, hey, there's a new restaurant very near to your house. Exactly whatever. Uh, I'm not sure. I'm not sure whether that's a restaurant or not. Maybe it is. Maybe it is. I don't know. But again, that's not a real that's not exactly what our main focus should be. So there are three use cases, or there are three business cases which Zomato tries to solve, right? Online food ordering, restaurant discovery, and advertising selling space, right? So first of all, even before we dive into the ML aspects of a Zomato, we need to always take care of the business use case that you are solving. Make sense, everyone? Business use case, the knowing of the business use case is one of the biggest thing whenever you want to solve any machine learning problem, right? Now, why is it so important? Why is it so important? Because without a problem, when you don't know what the problem is exactly, whatever solution you're trying to get to that problem will be useless, right? So you don't know what exactly the problem is, what solution will you bring, right? It's like a maths question has been asked that, okay, find X. What X? What problem are you trying to solve? You don't know what problem are you trying to solve, right? So getting to know the problem is the first step of any machine learning problem. And trust me, all of us, even including myself, sometimes try to skip that problem statement or knowing that problem statement in depth, right? So again, I always take a step back when I know that the solution is going nowhere. I take a step back, I understand what the problem is, and then maybe attack the problem in a very different way or the same way, whatever suits, right? Knowing the problem is one of the best things. Again, I know that today's session is more about Zomato, right? But I would try to inculcate a lot of things which from the learnings of Zomato, how can you take it to the outside place, at any place you are working, at any designation you guys are working, right? So that it is kind of a useful session for all of us, the 2 hours that we are all looking at. Everyone? Yes, no? Awesome. So now, how does the app looks like? So the consumer app, this is how you would typically look at the consumer app, right? Next, basically, so this is how the consumer app is. This is how basically the restaurant app is. So restaurant typically will show all these menus and all those things. And the third, who is the delivery partner, will have an app like this. Now, obviously, you need to know who are your user personas who will use your app. First is a business case, right? First is a business case. Next is basically your user personas who will use the app. So typically the app will be used by the consumer, the restaurant who is making the food, and the delivery partner who will actually deliver the food from the restaurant to the consumer. So knowing these user personas to build your app is one of the, again, important critical thing, right? Guys, is there a problem in the voice? Okay. Mughal, I think you would have to check your internet, please. Cool. So guys, everyone understood the user personas, the business use case. So two things we now know. One is the business case. Next is the user persona who needs to use. Make sense? Any doubts, any question? Guys, any doubts, any question? So somebody was asking, Fardeen is asking, Zomato is covering all three aspects or just focuses more on one part, like only on delivery part? Fardeen, think about this now. If you are trying to run a business, right? Think again, guys, whenever you're thinking that Zomato is trying to do that, put yourself in that place. You know? So think about it that you are trying to run an app. If you just focus on the delivery part of it and not on the consumer and the restaurant, who will deliver? Sorry, what will he deliver? From where will he deliver? To whom will he deliver? Right? Yes or no? Somebody was asking me this, right? On the chat. Pardon? Again, Suraj, now the thing is, if advertising is the main aspect to attract more consumers, think about it. You're advertising, you're attracting more consumers. But the consumer, when they see the consumer app, they don't know what to do. Will the consumer, even if you attract them to this app, they don't know how to navigate. Will they actually end up ordering? Think. Will they actually end up ordering, guys? Suraj, Fardeen? No, right? So the main thing is, it's very important for us to know your user personas and act on the basis of knowing your business case and then the user personas. Cool. Now, once we know what is the business case, again, the reason I'm always keep on writing is so that you guys don't forget. User personas, we need to know the right questions that needs to be asked in order to solve the problem in the business case, or the user personas, right? The user personas for whom you are trying to solve the business problem for, right? You need to ask the right questions. That when will this food order get delivered? Now, this is more from a consumer app. Yes or no? This is more from a consumer app. And this is more from a solving the problem of waiting time. Right now, categorizing all of these is again a very important thing, because I'll show you now that you have asked the right question how to solve it further. Right? How much time will the restaurant take to prepare this food order? Again, from a consumer app and waiting time. Right? Who should be the delivery partner for this app? This is more from the DP app. Yes or no? And this is more of like answering the business use case of earnings for the DPs, delivery partners. Is this photo a food shot? Again, this is more of the consumer app come the restaurant app, right? And the answer it is trying to solve is realistic, right? Is DP wearing a mask? Again, more for consumers, and DP app solving the problem of is that hygienic? Guys, so right, all the right questions that are being asked, right? All the right questions or all the questions that are being asked which are right needs to be for a particular problem statement and a particular user person. Yes, no, clear? Any questions, any doubts? Awesome. Cool. So now again, I'll not take a lot of time. Aman, yes, DP is delivery person. Actually, it's delivery partner, right? Not person, it's a delivery partner. Cool. So now, machine learning at Zomato, now when somebody sees this picture, right, into the brain, it gives the name of a pizza, right? Why pizza? Because that is its name. So we need to understand that in a machine learning use case, you have an input, you have a brain, which is nothing but the one who makes the decision, and finally the output. Okay. So now if the output and the input are known, if the output and the input are known, the process of figuring out the brain is called model training. Now, very similar to how kids learn, right? Now, this is where your machine learning thing starts coming in. Now, when a kid learns, right, it understands that there is some input that comes in, and against which or against an output, it tries to decide what will be the algorithm. Supervised ML, right? Now, think about it. Let me give a very I have a niece, right? Kiddo, right? So now, the moment she starts learning your fruits, right? So the moment she sees something like a red piece, very similar in size of an apple, she at the first she doesn't even know that what is this, right? So now, if you look at this, something in a red color, the shape of that, right? The shape of how it looks like has an output known as apple, correct? So these things, the red, the shape, are nothing but the features of the input. Everyone agrees with me? Red and the shape are nothing but the feature that is for that particular apple. Now, this apple is nothing but your output or something which is known as target. Right? Now, on the basis of this feature, let's say this is your y function, and it says that y is equal to, I'm giving a very mathematically lame example, right? That this x1 is nothing but how red it is, or what is the quality of redness, and x2 is nothing but the shape or how closer it is to the shape, right? So now if you look at just this mathematical formulation, now if something is red in color and the shape is pretty much very closer to the apple, you will typically say that the target is nothing but an apple. Yes or no? again, it's not a regression line, but I'm trying to just give an example of how kids learn so that you understand how machines also learn. Now, let's say the quality of this red is 90% and the shape that it is resembling an apple is 95%. Now with this M1 and M2, right, you will be typically very confident that Y is very close to something like an apple. Think about it. Guys, yes or no? Right? That is how my niece will make a decision. Right? Now, this decision is not on just one training data set. It is not on one training data set. She has learned it on thousands of training data set. And that's how she has optimized this M1 and M2, which are nothing but your learning parameter. Right? I'll repeat it again. X1 and X2 are nothing but your label inputs or your feature inputs. Now, on the basis of your feature inputs and the target value that is already told to her that this is an apple, with thousands of uh, data points, right? It gives us, or our brain, my niece's brain tries to get what will be this M1 and M2, right? Always trying to be as correct as possible, right? Always trying to be as correct as possible. Yes or no? So this M1 and M2 will be kind of adjusted with each training data set that goes in. And at the end, it will be so optimized that with a particular X1 value or a X2 value later on, right? And the M1, M2 value from the training data set, it will actually be, she will be actually able to understand whether it's an apple or not. So machine learning doesn't give it gives the logic, but it gives the logic with a it gives the logic which is mathematical in nature, or it allows it to be logically correct, you can say, right? So it is not only that it gives the logic, it gives basically the output or the mathematical interpretation of it to be logically correct. Did I make sense? Anyone? Yes, no? Any questions, any doubts? So the entire machine learning piece at like machine learning piece, not at Zomato, but everywhere else, right? These are supervised learning. There are something like unsupervised learning as well, because and in unsupervised learning, as the name suggests, unsupervised, there is no supervisor, so you will not have target values. It is just about that they give you like 5 fruits, and let's say 6 vegetables. Now, you don't know what are fruits or what are vegetables on the basis of different ways of how it is cooked. Is it eaten raw? Is it or maybe how does it look? Features. You will try to just cluster them that something which maybe is eaten raw, right? Something which is eaten raw might be mostly fruits. Something which is cooked might be vegetables. So on the basis of how it is cooked, what are the shape, what are the different ways of maybe buying it from the stores, you can actually try to cluster it, not classify, cluster. You can cluster them into fruits and vegetables. Again, you don't have as such any target variable that they are fruits or vegetables, with just the way of how those fruits and vegetables are eaten, maybe cooked, right? You can at least try to cluster them as cluster 1 and cluster 2, and then name it as fruits and vegetables. Clear, everyone? Machine learning, got a brief sense of the machine learning piece. Everyone, any doubts, any questions? Cool. So now, what are the different machine learning use cases that are there in Zomato? Again, to be very frank, these are machine learning use cases in Zomato, but a lot of these things are, what do you say, are very much, what do you say, usable across everywhere else. Now, so one is menu digitization. Now think about it. How many restaurants will be there on Zomato? Any idea? Any idea how many restaurants are there on Zomato? I also don't know. Again, let's take the entire India, right? Because Zomato is trying to solve this problem for entire India. So more than 10,000. Let's take a very ballpark number. Let's take a ballpark number of 10,000. Now there will be 10,000 into, let's say, 5 menus. Think about it. Maybe one for breakfast, one for lunch, one for snacks, one for dinner, right? And maybe another one is a bar menu. Yes or no? Now you have 50,000 menus, right? Do you think it is evenly possible for anyone to go through all the menus and manually update it on Zomato? Think about it. This is where your menu digitization comes in. Okay. Something like optical character recognition technology, a lot of these things of how you can digitize that entire menu. Because if you typically see a menu now, you will be seeing that what is the name of that menu is written here. Like in a, again, when you typically see any menu, okay, right? The name of the menu is written here. What is the content of the menu is written in small over here. And then the price is written somewhere over here. At least you can recognize that these are the three places in general where things will be written. Yes or no? Shyam, again, we have already crossed 30 minutes. It is very difficult to repeat something from the start, but it's okay. You haven't missed much. Don't worry. Let's start it with that. I'm just trying to give you more of a machine learning flavor of it. Okay. So you've not missed much. Don't worry. So it's not that you have missed something which will hamper your learning at the end. So don't worry, Shyam. Okay. Got it. So again, Rishabh, if the menu owner, if the restaurant owners are posting the menu themselves, think about it now. Rishabh, you are a restaurant owner. You are posting the menu and you have 50 items. Would you go to an OCR technology, get all the things which are very generic there, and maybe just look at correcting what is not correct? Or you will go ahead and keep on updating everything over there? Which one would you like? Let the OCR do a most part of it, 50-60% of it, and you invest your time on correcting which is not correct. Which one would you like? Second one, right? OCR is optical character recognition. So within a menu that is a picture, it will understand where the characters are there. It will recognize where the characters are there. And on the basis of that characters, it will understand whether it's a B, C, D, and it will start putting those characters as a name. That is OCR, optical character recognition. Clear? Everyone understood how machine learning? Yes. There is an example. Don't worry, I have examples. So if you see here, fries, burger and coffee, right? Again, this is from a digitized menu, but this is how typically it looks, right? So from here, it actually tells, okay, this served with brown bread and the amount of it. Make sense, everyone? What is a text detection or a OCR? See, whoever was asking, give an example. Drishti, see, I read your mind also. Okay. Anyways, jokes apart, everyone clear what is menu digitization? Okay. Now, next, let's come to the personalized homepage restaurant listings. Now, every restaurant would need or would like to have the personalized homepage. Every restaurant would like that. Now, obviously, you cannot personalize homepage for everyone in a very different way, right? What you can give them is a custom homepage and allow the owners to like drag and drop to personalize it themselves. Think about it. You know, everyone would have a taste of color. Somebody would like yellow, like different shades of yellow. Somebody would like different shades of green. Somebody would like different shades of blue. So but typically, if you look at the homepage of every restaurant, at the top level, it will be mostly very similar to each other. It's just that the color, the grass, or uh, the ambience of how the restaurant owners want to show is a bit different. So you create a homepage for the restaurants and allow them to customize it as per their taste. Again, a machine learning use case which is used by Zomato. Now, what it does is, according to the food or the photos that you have put in, it will also start recommending, hey, you know what, do will look good. So you can actually try out different, background things at the back, customize your homepage. Those recommendations are also provided by Zomato. Clear, guys? Everyone? Any doubts? Any questions? And if I'm not wrong, so for example, there are, if I'm not wrong, and if I read it correctly, there are light GBMs, light gradient boosting methods, right, to achieve this optimization. So there are different high fundu machine learning techniques which are used to do that, right? Again, not going into depth because we have not even started machine learning, but okay, just to give you some aspects of how it looks. Okay. Now, the next thing is the way Zomato has the revenue is through gross merchandise revenue, and AOV, which is known as average order value, right? Now, this comes to the important part. Now, how they do it, and if I again remember it correctly, it is multi-arm bandit method. Okay, I'll come to this multi-arm bandit method in a bit, right? So think about it that you are looking for something on, let's say, our Amazon and Flipkart. You know, looking something on Amazon and Flipkart. Now, you would have a particular taste when you're looking for a laptop. Maybe you prefer only Dell and HP. Think about it, right? Again, I'll not name any brands because I think this is live streamed and not. Let's say you like brand one and brand two. Clear? Now, on the basis of your interest, right, you will typically see Amazon or any of these e-commerce websites showing you the brands which is in line of your taste. It knows how you have interacted in the past. Yes or no? It is in tandem with the interest. It is in tandem with what you like. Similarly, if you look at Zomato, it knows that you like more of Indian. It knows you like more of Chinese restaurants, right? So you would actually see, and I don't know whether you can see, but I have seen in my Zomato app that I typically like a lot of Bengali cuisines when I'm here in Bangalore. It literally, when I write, let's say chicken or something, right? It literally shows me Bengali cuisines at the top. Why? Because it knows that I am fond of Bengali food here when I'm in Bangalore. And when I see Bengali, I'll typically tend to order that irrespective of anything else. What in turn it will do? It will increase the average order value. That means the value or the amount that I'm using to order it, it will literally increase that order value in short. Yes or no? Guys, did you understand the way of how they are trying to solve the problems? I know. Now, the way Zomato has solved this is using multi-arm bandit. Now, I don't know whether I'll do justice to explain multi-arm bandit, okay? But I'll just try, okay? I'll not go into any of the other things in a quite very mathematical, but I really love multi-arm bandit. I'll try to explain in a very simple way if you guys are okay with it. Yes, no? Do you want me to go into the multi-arm bandit? Okay. So let me do one thing also. Good. So think about this. Everyone knows what's a casino, right? Okay. So you have something like a roulette. Guys, I'm not going into the mathematical aspect of it. No optimization functions and all. A very simple way to understand how multi-arm bandit works. Okay. So have you seen all of these? Kind of there is a lever. If any one of you have seen Friends, right? You would have seen Phoebe sitting in that roulette wheel, right? If any one of you have seen Friends, right? So now let's say this is a person, right? This is our Naren from AlmaBetter, who has all the coins. Okay, he has all the coins and comes into the casino. Okay. Now, obviously, at the first, when he looks at this, let me color them. Okay. This is green. This is, let's say, blue, or maybe dark green. Let's say this is this color. This is this color. Okay. This is, let's say, okay. These are the 5 colors that are there. Cool enough? Okay. Now, let's say Naren comes here, and at the first thing, what he will do, he will actually go to that particular casino which looks attractive. Think about it. Anybody, when you don't know what different roulette wheels are there, either you will go to the roulette wheel which is attractive, or you know another thing, you'll be like, okay, I am spending 1 token each at each of the roulette wheels. Yes or no? Or maybe 2 tokens. Now, on the basis of using these tokens, let's say you get a probability that there's a 0.9 chance of winning, there's a 0.2, 0.1, 0.5, and 0.8. In the next step, what you will do? Will you actually go to this, and this? Will you actually go into all 3 of them? Mostly not. You will typically put your next set of coins here. Guys, everyone able to understand this? Like, I'm going in a very easy way to make you guys understand. Okay? You will typically put your 3rd coin here. Now, over a long period of time, you see that this particular thing goes down to 0.1, this goes to 0.1, but in turn, this becomes 0.95, 0.8, sorry, this is 0.1, and this becomes 0.5. But over a long time, you will see that the amount that you are putting in, or the coins that you are putting, will drastically start reducing here and start increasing. So with every space, with every turn that you do, you will actually see that you start putting in a lot of money over here and here, rather than this one and maybe this one, which at the start you thought that would be giving you the most money. So what in turn happened here is this is more of known as a reinforcement learning. A reinforcement learning where after every step there is a decision change. There is a decision change. And this is very adaptable, and this is very, what do you say, very uh, dynamic in nature, very much dynamic in nature, right? This is how robots also learn walking. A biped robots actually learn walking as well. It falls down, it gets a penalty, it gets a reward. On the basis of the penalty reward, this thing, uh, the robot actually starts walking. Okay? I don't know what is Simpson's paradox, by the way. I'll tell you the shit how Zomato uses this, but at least everyone got to know how a reinforcement learning or a decision making works. Is it simpler for every one of you? Guys, easy, right? So the reward penalty mechanism is more of like, they call it as exploration versus exploitation. Again, I'm not going into that. I'm just giving you what is the basically the reward this thing mechanism, exploration versus exploitation. Yes, clear, guys. I just tried to be very simple. I know I didn't tell any mathematical formula and all. It's just a very clear, like a very layman representation of what reinforcement learning is. So again, there are mathematical formulations of a reward penalty. I will not go into that, otherwise half of the people over here will get confused. Okay, that is for some other time when maybe we do reinforcement learning and all. We will try to cover that. Okay. Think about it now. I'll give you a very clear this thing. When somebody, so I had a pet, I had a dog. So when I used to train the dog, think about it that you give them rewards, right? Treats and all those things. Everyone knows, right? So when you tell your pet to actually sit down and it sits, you reward them. So it knows that it has done the right thing, right? So there is already a mathematical calculation that is going in his mind that when he tells to sit, I'll get a reward. The moment I tell it to sit and it runs around here and there in the house, there will be a penalty attached to it, right? Maybe I'll not talk to him. I'll not maybe listen to whatever his bahane, his manmani and all are, right? So so he has a calculation running in his mind, a brain calculation, right? So this is how a reward penalty mechanism actually works. Got it? A very layman perspective. Again, I'm telling you, I don't want to go into the mathematical aspect of it. So if that answers your question. Okay, so how will it decide that outcome is decreasing in A and E? So it is, yes, there is a programming, Sham. So reinforcement learning also has programming into it. So how A and E, like how does it know that in A and E? So with every step or every coin you put now, so with every coin you start putting in, obviously you'll see that I'm not getting rewards. With every coin I'm putting, I'm not getting reward. So the probability of winning will automatically start coming down. That means it's basically a penalty that you should not be putting any more coins here. So this is how, with every step or every coins that you put, you start kind of rethink on the basis of the penalty and this thing, and use that dynamism to come out with where do you want to invest your next coin. Clear? So I don't know whether it's there, but I'll just speak it out. Okay. So what they do is they use this multi-arm bandwidth. So they use features like maybe order value distribution, right? They use things like order value distribution between customers and restaurants. So there are a lot of customers, a lot of restaurants. So they will look at a lot of order value distribution. Then think about it that with every order that you give, right? With every order that you give, what it will try doing is maybe it will start increasing the weight for Bengali cuisine for me, right? Bengali cuisine for me, and maybe for Chinese, because I've not ordered Chinese for a long time. It will start reducing the the weight of the Chinese restaurant. Let's say after a few minutes, I'm actually getting or I'm actually ordering the food for my wife, right? She may be like Chinese or Indian or tandoori kind of pieces. So automatically with every order that I'm doing in Zomato, it will start updating the weights in that particular way, so that at the end of the day, it starts showing me a lot of Bengali cuisines and Chinese cuisine that suits me and my wife's taste, interest, or whatever our cuisine likes and dislikes. So that is how it uses multi-arm bandwidth to kind of give you recommendations so that you end up ordering from Zomato with whatever you want. So it increases the GMV, right? It increases your GMV or maybe AOV, which is the average order value. So if I start saying chicken dish, if I say chicken dish, right? And it shows me a Bengali cuisine ka chicken dish at the start, or two Bengali cuisine ka chicken dish at the start, two Chinese chicken dish in the next two, on the basis of learning what the previous orders of mine were. Don't you think I'll end up ordering things from here rather than going into any other app, right? So it starts increasing the average order value for every time I log into the app to order. Rishi, does that answer the question? Right? And again, if I'm not wrong, according to their blog, they were able to increase the average order value by 6 rupees long back. But they were able to do an increase of 6 rupees per order. Think about 10,000 orders a day. So on an average, 60,000 increase in the revenue. Yes, cool, everyone. Understood? Again, this is just to give you a highlights of some of the classical machine learning things, reinforcement learning things that are used day to day. And it will be totally injustice if I don't talk about the machine learning things which Zomato uses. But again, I don't want to go into the mathematical aspects. It is all like it is for the later part when we actually deep dive into reinforcement learnings maybe at some point of time. Cool. So going ahead, menu digitization, personalized homepage listings. I've already told about this. So will this be the case that in doing so that they would be sometimes favoring a particular restaurant? Fardeen, not necessarily, because if they are favoring a particular restaurant, that is not helping them getting a lot of orders. No? Why would they do that? Again, if there is an advertising space that they have sold, obviously it's not favoring. It's kind of utilizing or giving them that space, giving them that advertising space. So that is different, right? But in other cases, it won't be favoring a particular restaurant. It is all for the customers that they would be doing. Okay. Again, as I was saying, that personalized homepage listings, they have something known as Lambda Mart, offline GPMs, and all those things. Again, I'm not going in depth of them. This is the most important thing, which is your food preparation time. So if you have seen Zomato tells that your order will be delivered in so and so minute, how does it know? How does it know? Have you seen, everyone? It shows that your estimated delivery time will be this much. right? So it gets to know from the obviously the food preparation. So the average estimated delivery time is your food preparation time and your delivery travel time, right? So while they do that, they use, if I'm not wrong, again, I don't know whether they have changed it or not, but according to their blogs, they use something like an LSTM, which is long short-term memory, long and short-term memory, right? Again, a classical use case for in a deep learning methodology to kind of predict something in the future, like a time series, right? A very classic example or machine learning algorithm to solve a time series problem, right? The main part of an LSTM, again, I'll not go into LSTM, is, as the name suggests, it's a long, short term memory. So what is a long term memory? Think about it that, okay, when you decide something, I'll give again a very layman term. When you decide something, you would have an aspect from a long term memory that when I did this 3 years back, this thing happened. Every time, but whenever we make a decision, I will be like 3 years back this happened, and on the basis of that, there will be an element that will help me decide. And there is a short-term memory, right? That I invested in this particular company few months back, and on the basis of that, I'll take the decision. This is exactly how long short-term memory works, right? So this is how you to predict something whether I should be investing in this company or not. You always look into the long-term memory, the short-term memory, and the combination of the long short-term memory is known as LSTM. Simple, right? Again, keeping it very simple right now. So there are a lot of, not really. Every food preparation time will also have a long-term memory. This will have a short-term memory. This will also have a long-term memory. This will have a short-term memory. That when I delivered to Harsha's place last time, how much time did it take? 1 year back. Now, how much time it will take? So it kind of balances the long term and the short term. So it's more of a balancing using a bidirectional LSTM in order to make the final decision. Clear, everyone? Okay. Now, again, so this is achieved through a bidirectional LSTM based deep learning model that takes into account all the features. So basically, what is the restaurant's behavior, maybe, and what are the type of dishes that are ordered? Maybe something which is a tandoori, it might take a lot of time. Something which is Chinese might take a less of time, right? So the type of dishes, the quantity of the dishes. If you're ordering 200 dishes, obviously the FPT, which is your food preparation time, will be like drastically high, versus 2 plates. Correct? Time of the day, whether there is a football game that is happening in the restaurants, the day of the week, all of these are numerous factors that affects your FPT, and this is solved by using that long short-term memory I was talking about. Yeah, Rishabh. So that's what is now your FPT, food preparation time. So it predicts it from the start itself on the basis of the different features that they already use in order to do that food time preparation prediction. Rishabh. Right. So this is another use case, very interesting, enhancing road detection. Right. So now, okay. So guys, everyone clear till here, by the way, because I think 2 more case studies are left. Interesting on how understanding how machine learning is used in your food delivery pieces. Awesome. Now, enhancing road detection. Now, again, this we as humans now we generally do a lot. Okay, but how does Zomato knows about it? How does Zomato knows about how to enhance road detection? How to update some of the ETAs, time services? Because if you look at Zomato's goal now, it promises that after a particular, so after that FPT, which is a food preparation time or the delivery time, it gives you some, if you're a Zomato Gold customer, it will give you some cashback if they are not able to deliver it on time. Have you seen that? How does it ensure that they don't have to spend a lot of time or a lot of money in doing that? How does it ensure that you don't have to? So this is where they're clear their master stroke of enhancing the road detection. So what they do is, this is the ground reality. So let's say whether I can see this or not. I don't know which. Okay. So if somebody has to come from this particular location, to this, hey, why is it not? 1 second. If somebody has to come from this location to this location, right? What it will do? Don't you think it will actually? It will actually take this road, come here, take this route, and maybe reach here. Yes or no? Right? Or it can also take this route and reach here. Now, what it does is it gets this vanilla OSM, right? It gets something like a vanilla OSM. Again, I forgot the full form of OSM, by the way. So think about it that there is a place here, and the next place is over here, right? So in this, it is very easy to see basically the road that I already drew, right? These are the two places of where it can go. So like from this ground truth, they have a vanilla OSM geometry. Order and service management. Okay, thank you. There's so many short forms that I tend to forget sometimes. Thank you, Suraj. So what happens is now, okay, it knows that, okay, if I have to go from here, point here to point here, these are the two road directions I can go. But if you look here, if I have to reach here, then I would try to draw it with a different, this one, and maybe here. Okay. If I try to draw here, don't you think that if there would have been another delivery guy who would have taken this route, which is very different from this particular route, which is not even visible over here? Have you seen the yellow route which I drew now? Right? And this route takes 40 minutes. This route takes, let's say, 50 minutes. And the shorter route, the shortcut route, let's say, takes 25 minutes. Don't you think that on the basis of different pings, because whenever your bike or your delivery partner is on a particular road, it will literally ping that, okay, I'm here, I'm here, I'm here. And that way how you track. But if that delivery partner took a very shortcut route like this and reached in 25 minutes, don't you think Zomato will actually enhance the road detection? And next time it will actually direct the delivery partner from here to take this route instead of this route and this route. So it uses humans, humans way of judgment also in order to enhance the road decision. Because only a human can look at shortcuts where a bike or a small gully through which a bike can go. And of course, this leads to a very cross-connected maps. So ETA accuracy increases, you have better routing, you have better addressing of the entire routes. Exciting. Have you like literally all the things we do in our day-to-day life as a human? Yes. So this is how we do day-to-day. If I have to come from my office to my home, I know a road in between which is only only possible for a bike to go, right? So I'll actually take that route. I'll not take the Bangalore traffic, the actual route which comes in the Bangalore traffic, right? So this is your augmented geometry. Augmented as in the drivers are helping in augmenting the geometry with the missing roads or the missing routes, which enhances the road detection. Arrows are meaning nothing, that there is a road like this where a particular delivery partner actually went through. So this is more of like that. What you say, shortcuts, you can say. So there is a road from here to here. Maybe the delivery partner went from here and it didn't go ahead. Maybe there is a block over here. So since there is no connectivity, he might have returned back over here and so on and so on. So vanilla OSM, Akshat, vanilla OSM is nothing but uh, a very base. So from this ground truth, they made a very a map which is like a vanilla. Think about vanilla ice cream. It doesn't have any flavors or anything, right? Pure vanilla milk ice cream, right? So what they did is they made a vanilla map, right, with uh, which has routes that everyone knows, and then they try to enhance the map which with the uh, road detection or enhancing the road detection. Okay. Now finally, I don't know why they named it as. Okay, this should be actually not Zomato, Domino's Pizza. Should be Zomato pastry. Right? Sorry, guys. Cool. So now, so with this, what do you say? With the COVID and all coming in, right? Have you seen that it was a mandate for every delivery partner to kind of uh, kind of show that they are wearing masks when they uh, deliver it, you know? So what they used to do is they will be like, okay, just put the mask over here, right? So take a selfie wherein the mask should be here, and it just looks at whether there is a mask on the face of that particular delivery person. It needs to submit in a certain amount of time. It is not like when you click on delivering, you know, and you take out the mask from the pocket, you wear it, right? It doesn't allow that. 30 seconds, click a selfie and submit it. Otherwise, you'll not get the remuneration. Simple funda, right? So that all these audits are, and it has to give that output within the next 20-30 seconds as well, that are you wearing a mask or not. So that's the what do you say, that's the way of classifying whether you're wearing a mask or whether you're not wearing a mask. Clear, everyone? Right. Another thing I think which is not here, guys, everyone clear? Because I really wanted to discuss one more aspect of the Zomato case study. I don't know how many of you are like interested in the next active TP dispatch, but more than happy to discuss that because I have some time. So, okay. So, who was asking this? Somebody was asking, how does it judge? Who was discussing? Who was asking? Arun. So what it does is, okay. So it uses something like a convolutional neural network, CNN, what we call, right? So what it does, there are things like in this like edge detection. Okay, think about it. Then pixel difference. So there will be a pixel difference between this area and this area, because this is blue in color, this is skin color, right? It tries to detect the edges. It tries to detect whether there is a nose, there is a mouth already visible. So on the basis of the feature, it tries to determine, is there a nose visible? No. Is there a mouth visible? No. Is there a beard or a mustache visible? No. So of course, if all of these things are not visible and there is a clear gradient of the color, so most probably 90% the person is wearing a mask. Again, not going into the technical aspects of it, but a very layman way of explaining. Does that answer your question, Rishabh? Or whoever was asking? Cool. So obviously, if you are not wearing a mask, your account is blocked for 1 hour as you are not wearing a mask. After many reminders, always wear a mask while delivering. Okay. So in this way, they make sure that the delivery person is always wearing a mask. Okay. Cool. The next part, the active delivery partner dispatch. So there is something known as active delivery partner dispatch, right? So now what happens over here now? Sometimes if you see, your delivery partners will have a preference of the location. Yes or no? And preference of a location mainly because of where they stay. Maybe they stay close by. Maybe that is the place which has maybe high orders. Yes or no? Right? Okay, by the way, I'm looking at a different screen. I have the chat in the other piece, so I didn't say that at the start, but I'm looking at the chat on the other screen, so that's why you might not see me seeing on the camera. I completely forgot to say. Anyways, so the delivery partners have a preference location, right? So maybe they stay close by, or they know that at that point of time they will have a higher order or something over there, right? Now, what this creates is actually an acute difference or a barrier, I would say, a barrier which can create a demand supply gap. Yes or no? It can create a demand supply gap. Yes. And maybe at some times, if you have seen, especially during rainy times, a lot of restaurant actually close taking orders, right? You can actually they actually close down a lot of orders. Yes or no? A lot of restaurants, sorry, right, during the rainy seasons, right? Because obviously there is an acute demand supply shortage. So what they have done is they have used something like a queue network reinforcement learning technique. Okay. And what it does, again, a big, this is more of a reinforcement learning, but what it does is using this, it starts recommending the delivery partner that, hey, you know what, if you go like 2 kilometers more than your designated area or wherever you are right now ordering, you might in turn have a bonus of 70 rupees per order. 70 rupees per order, maybe, just to make sure that there is no demand supply gap. And in this way, what they do is to the customers, have you seen that they give a surge fee? Right? So this is how they control the entire demand supply gap. So they have a deep queue network. I think I don't know whether it's a multi-agent or a single agent. I think it is multi-agent queue network, multi-agent reinforcement learning technique. to recommend a delivery partner that, hey, if you travel this much more kilometer, you might end up making a lot of money, and there are a lot of orders which you can deliver. So in one point A to point B to point C to point D, which might be a 5 kilometer route, you can actually deliver 10 orders in one go, and you can easily make, let's say, 200 rupees or 300 rupees as a bonus. Right? So it accurately, so this reinforcement model actually allows accurate prediction of the demand, of the supply, so that all of these things are taken into account, the routes and all those things, and put in a particular methodology so that the demand supply gap is reduced, and automatically the surge fee is incorporated into each of the orders that are being put. Yeah, everyone? So somebody was asking about late night. So this is how also, right? Recommendations. These are some of the things. It's not just about rainy seasons. It's about any time there is a demand supply gap. Simple. Guys, any doubts, any questions? Similar offer for restaurants. Okay. I'm not very sure, yeah. Similar offer for restaurants. Demand supply, I'm not sure. I can't comment on that, because again, we have got all this information by scouring different places where Zomato has put their blogs and all those things. Right? So I'm not very sure. How discounts are decided for different restaurants? Again, there are a lot of elasticity, price elasticity, and all, right? Which is more of a revenue management piece of it. Again, machine learning is also used over there in order to understand what would be an appropriate discount so that it doesn't go into a loss. So that is another piece of it. Again, it was impossible for me to go through all those this thing of the use cases. My main idea was to give idea about those use cases, which I'm very confident about, because these are written on this on the blogs and all lot of things. Again, obviously, Sudhanshu, Zomato will not reveal how discounts are decided for different restaurants, I think. So again, I might know, but I'm not very sure. Clear? Please give me 1 minute. But everyone clear with whatever was today's session all about? Interesting stuff, everyone? Okay, so just give me 1 minute. There is a quiz for every one of you. Right, just let me open that quiz. Just this that I had to re-log in. Like you guys just give me 1 minute. Just so I've started it. AlmaBetter team. Anything before you want to start? Before I start the quiz, anything you guys want to?
Yeah, I think we can start the quiz now.
Okay. So I hope there are prizes also for after this quiz. I hope so. And also, guys, I
Yes,
think
we will be giving gift vouchers to the top three winners of this quiz. So yeah, we can start.
cool. And I think Naren has already put some feedback comments. Would love to know more about your thoughts, your guys' thoughts about the masterclass. Would love to incorporate them into the next masterclasses which I'm taking or anyone else's too. Right.
Mm.
So without much further ado, let me just start the quiz. Okay, so you guys can join in here. Maybe two ways of joining. Just click on the link which I gave, or you can go to kahoot.it and it will ask for a pin. Just add the pin, which is 138. Guys, please join in with your real name, right? Because it will be very difficult to kind of give the gift vouchers to you. Anyone who has joined in Shop, I don't know, RS, right? Guys, please join in with your real names. Somebody is like GST, again AS. Guys, everyone else has joined. Shall we start? Again, I don't, guys, we don't know who is this, right? Guys, with your real names, please. You don't want gift vouchers, yeah? Okay. Naren Gurneet, if anyone gets a prize and you don't know who it is, I'm ready to accept that prize.
Yeah, I don't think that we can give the gift
No, no, I'm
vouchers if you
saying,
want to.
yeah, that's what I'm saying. If somebody has joined with SBHRK and they win the prize, I'll accept the prize. More than
Okay,
happy.
done. Done.
Cool. Guys, let's start. So guys, that's what I'm saying, right? If you want the prize, no, Suraj, I've already asked that first come, first serve. If there is a confusion, the prize is with me. I've already asked for it. Cool, guys, let's start. Again, the questions are a bit tricky, so let's see. It's a restaurant search optimization, guys. Okay, see, filtering search result based on cuisine preferences. They don't filter it. They don't filter it. They give weightage. On the weightage of that, they match. I told you very clearly, right? It will be a bit tricky. So they don't filter it, they match. Guys, be very careful about the words that is getting used. It filters, it filters on the search queries by matching it with basically the restaurant attributes that this restaurant provides Bengali cuisines, this particular. So it doesn't filter directly, it does a user query match. Okay. Yeah, Ashwarya leading. Personalized recommendations. Guys, be very careful. I'm telling you at the start. I've already told about this as an example of an Amazon, from an Amazon example. Perfect. Good. Great going, Ashwarya, Monica, and Drishti. Very close competition between Drishti and Monica. Okay. This is also a bit tricky, by the way. Tricky between two options. I knew. So see, it doesn't optimize delivery routes by calculating estimated time. It calculates estimated time by optimizing delivery routes. It's the other way around. Okay. So it determines the best pickup and drop off locations and the route between them, basically. Right? Whoa. This thing is like, there's a meme, right? The entire scoreboard is like flipped. So Anjali on the top, Shahib and Abhishek. Great. This is out of the scope a bit. Let's see. This is very easy, by the way. I know we didn't talk about this, but this is very easy. Good. Great. Okay, Anjali is still leading, but very close competition between Shahib and Anjali. Okay. Last question for the podium prize. Ten seconds. See, it doesn't predict user satisfaction, no? Based on delivery time estimates. It just gets the user feedback, right? It doesn't predict user satisfaction on the delivery time estimates. How can you this thing like so? Cool. Let's see who's on the podium. Akshat, good one. Anjali. Oh, Anjali was leading. Who is at the top? Shahib. Shahib take the first position. So Aman is fifth. Okay. So guys, this is what I had from my end. Any doubts, any question that you would like me to answer before I hand it over to Gurneet? One more quiz. Unfortunately, I don't have one more quiz. We want your sessions more. Awesome. I would love to have more sessions with you guys. So that's it. Then, guys, please do fill up the feedback. Would love to hear feedbacks from you guys. Would love to incorporate some of the feedbacks as well in the next this thing. Please use OYO case studies. Okay. Cool. So that's it. Gurneet, over to you.
Thank you, Arnav, for such an insightful session. Like I personally enjoyed it and gained so much insights from Zomato's things, and I really enjoyed it. I'm hoping that all the participants also enjoyed it. So yeah, so before that, now I would also like to congratulate the top three winners of our quiz. And please fill out the feedback form as well so that we can arrange our prizes as to you guys. And yeah, so I'll be just sharing my screen. I'll just be taking your 5 to 10 minutes to explain about AlmaBetter. So wait, let me share my screen. Give me a minute. Right, you can see my screen, right?
Yep.
Yeah. Okay. So let's talk about AlmaBetter. So we are making a positive impact on students who want to enter the field of data science. So what we do here is we divide the like for the students, we arrange for them to study in groups, right? And then we try to make them projects in make them do projects in teams, and then you get ready for work, right? Next. So you would have a question, why do you need to join AlmaBetter? So by joining AlmaBetter, you become a part of a thriving tech community that prioritizes your career growth, right? And we are revolutionizing online learning by delivering relevant skills, valuable experiences, and tangible learning outcomes. And our goal is to fast track your career and equip with the skills of tomorrow, right? And we are committed to providing a learner-centric experience, preparing you for a successful career in data science domain. And our approach is also like it focuses on delivering job-oriented learning and traditional education and within the industry demands, right? And we also understand the importance of hands-on experiences and collaboration in real-time work environment. And that's why when you enroll in our course, we place you in a group of like-minded individuals, right? So 5 to 6 members are there in one group, right? So what we do, you have 6 to 7 months of learning. You'll be studying together. You'll be working on projects together, and you will have a stimulate the work environment, building essential skills for your future career, right? Then your path to success is you sign up and enroll. Then you start your learning and for your journey, and then you get certified. Then you sign the ISA and get your course fees refunded. Then you start your placement program, which is Alma X, and then after that completion, you land your dream job. So learning activities for technical skills, you provided live lectures, lab experiments, projects, and assignments. And we have group discussions. For motivation as well, you can get one-on-one mentorship with our instructors, you get guest lecturers, and you have community participation, right? And whatever is mandatory for Alma X, we have capstone projects, and we have challenges which makes you more confident, and you can just be ready for your industry experience. We have more than 500 companies hiring from us, so you will get a guaranteed placement. Then the salary distribution of AlmaBetter graduates is minimum package, which we give is 5 LPA. You will be getting 5 LPA packages. And as you can see the distribution chart as well for the salary. Then you have your instructors and mentors, right? These are all your instructors and mentors, Soumya, Abhinav, Mradul. So as you can see, then these are the people who got placed, Akshay, Soumya, as ML engineers in data analytics, right? So now I'll take you a walk towards the student dashboard. So so this is the, so this is you can see the tab, right? So in this one, this is once you start learning, for example, this is a full stack data science course. So you will be having different modules, like 6 modules you have, which covers your computer programming, then your Python, database, data visualization tools, and statistics, right? You have more than 6 modules and 32 lessons. Then we have a classroom where you get live classes scheduled for you once you enroll with different instructors, right? And then on the practice on sessions, we have 50 problems. We have coding assessments. We have quizzes, which will prepare you more. And in projects, we have 31 projects, which you'll have to submit. And you have to, for Alma X eligibility, you have to achieve more than 70%, right? So as you can see, all these projects you have to complete. Then for the career, Alma X, once you enroll, like eligible for Alma X, you will have this, all these modules. And then you will have to take a assessment test, right? And then you also have, for mentorship, you can also book a session with our instructors for any doubts you have, right? So I hope that you enjoyed today's session, right? And please do fill out our feedback form for future references, for our future masterclasses references. So yeah, thank you for our masterclass. And thanks, Arnav.
Thank you, Gurmeet. Thanks, Miriam. Thank you, everyone, for joining and staying until the end.
Thanks, everyone.
Thank you.